Welcome. This is part 8 or concluding part of singly enforced sections. Last class, I told the application. In one question, I explained how to find unknown UDL. One question, unknown point load. Go through the questions. And lot of concepts are told about factor of safety. That is factored load, working load, etc. Now I will not tell further. This question, I am going to check the safety. As I told already, I will not repeat. If unknown is there, I told equate. If check the safety required, compare. Someone will ask, compare what? Leave it. See the other classes. Okay. Practice question 3. See. A simply support beam of effective span 5 meter is of cross section 200 by 500. Tension reinforcement consists of 4 bars of 20 mm. See, beam width is only 200. In 200 width, 4 bars cannot be placed in one row. So what I made? I placed in 2 rows of 2 bars each at a clear cover of 40 mm and a clearance of 25. This I will tell you. Beam is loaded by an UDL of 17.5 kN per meter excluding self weight and a point load of 40 kN at 1.2 from left support. Taking M20 and FE 500, check the safety. Write the question first. Solution. First write the statement. We are asked, you can write, we are asked to check the safety. So, for safety of the beam, factored maximum BM for the beam should not exceed ultimate MR of cross section. Okay, so first, find what is factored maximum bending moment. For that, one sketch I written. Whatever is the given loading, see here, 17.5 kN per meter UDL. But it is told excluding self weight. So real UDL is 17.5 plus self weight. Point load 40 at 1.2. First find self weight. 0.25 into 0.5 into 25 will come 2.5. 17.5 plus 2.5 will give 20. That's why I gave 17.5. So that to get a round number. If I give an odd value, sometimes decimals will come. Just to make things easy for me. That's all. Now, therefore, a statement required, intensity of UDL equal to 17.5 plus self weight is 20 and point load is 40. Remember, these are all service load. You should write it. When it is given that beam is loaded by means, it is service load or actual load. So, but we want factored BM. So what to do? Take gamma F equal 1.5. This 20 multiply by 1.5. You get factored UDL 30 and factored point load 60. Now, class, draw a neat sketch of beam. See, this is the factored loading. I told 30 kN per meter UDL, 60 kN point load at 1.2 here. Span is 5 meter, remaining is 3.8. Now, some statement you should write. Now, you required what is the maximum BM for the beam. BM for the beam. By chance in the question, you should make a note. Only UDL given. Direct answer, WL square by 8. Suppose UDL, self weight is always there with the central point load. WL square by 8 plus WL by 4. Or if cantilever given, simply take moment about the fixed end, that BM hogging will come. We covered it. Now, just to see that you understand it a little better, I have given unsymmetrical beam. Right here. Loading is not symmetrical. So you cannot apply formula. You have to you should write all these things. Maximum BM from first principles. Now, first you have to find reactions. First of all, I should not tell how to find reaction. I am not writing. See, this is question mark. Means calculated value. You have to check it. See, take moment about A. Minus VB into 5 plus 30 into 5 into 5 by 2 plus 60 into 1.2 equal to 0. VB will come. Sigma V0, you get the value of VA. Now, suppose someone will tell, sir, we don't know all these things. Then why are you studying RCC first of all? Okay. Loading diagram ready with the reactions. Now, maximum BM you want to get. What you have to do is, in the YouTube, you go to playlist. There you can see a course called SFD BMD. Around 130, 140 classes are uploaded. Class number 48, see right here. Class number 48, same question is there. But same means not 5 meter span, not 30 kN per meter, not 60 kN. A beam with UDL and a point load, eccentric point load. There, I remember, I put the point load at different positions so as to get different types of SFD and BMD. So there, one of the cases, I will tell you, I will draw the SFD BMD here now. Actually, if you want only maximum BM, I will tell you how to calculate. But actually, if I tell, you will not be able to understand properly. I got a trick. I will tell you now. See, if you understand the subject, you see how much the tricks are possible. I will find the maximum BM now without drawing the shear force diagram, without locating that point, and without finding BM there, directly if you want. This reaction is, I know maximum BM will take place this side. Why means, don't ask me. Trick it is. Square this number. This will not work out for all the problems. You should be careful. Never try what I am doing. Danger. Sometimes the students I will tell, what I, sir, they will tell, next time, sir, your trick is not working. Yes, that trick for that question. Sir, how you got it, sir? Not for you. Okay. Trick now. 89.4, square it. Square, divide by 60. That's all. 133.206. 133.206. That's all. That's all. Okay, leave it now. This just to show you that if the subject grip is there, what you can do. Now, so refer to class number 48 in that course. See, there, question subdivision, A, B, C, D, etc. is there. One question load is very near here. So many cases are there. You select one of the cases there, which will match with this, or you study all the cases there. Study all the cases. This is one of the case. Okay, now, without explaining much, because this class is not for strength of materials. So therefore, without explaining much, I will draw SFD now. Shearing force diagram. Sign all I will not write. 120.6. See, I told you, I already got the bending moment maximum. 120.6. Then come down by 30 into 1.2. 84.6. 84.6. See, if I had given a simple only UDL, I could have escaped here. By this time, WL square by 8 over. You write, make a note. This is just to see that you get extra information. Down by 60. 24.6. Down by 30 into 3.8. 89.4. It should be equal. Go up, over. This is the point where shearing force diagram crosses baseline A, B, C. I will call this point as D, a special point. I use a red color, want to understand. I use red color for that one. Just to understand only. Actually, red color are not required. Still, to understand, red color. Okay. It is an important point, D. Let it be X from here. Calculate X. You can do so many ways. 89.4 divided by X equal to 24.6 divided by 3.8 minus X. Or I explained there, you calculate X. That X will come 2.98 meter. 98 meter. Now remember, now we will draw bending moment diagram. But one important, we do not want bending moment diagram. What do you want? We want factored maximum BM. Factored maximum BM will be at this point. So it is sufficient. You need not draw bending moment diagram. Find bending moment here, but still I will draw it. Bending moment here 0, bending moment here 120.6 into 1.2 minus 30 into 1.2 into 1.2 by 2. 123.12 here. 123.12. Then here 0. This point I want bending moment. that red color point. Look that side. 89.4 into 2.98 minus 30 into 2.98 into 2.98 by 2, 133.206. 133.206. See what I told? What I told? See, tricks. Okay, now, this is one parabola. From here, slope will change. It will become little flat. Actually, it will be little steep. Actually, that's all not important. No. This all I explained there. Okay, something like this. Okay. Therefore, right here, factored maximum BM. This is the what? This is the BMD. This is BMD for what? For factored loading. Remember, factored maximum BM for the beam equal to 133.206 kilonewton meter sagging, bottom tension, top compression. If you want, you can write at where? 2.98 meter from B, right support. Okay. Now you got factored maximum BM. Now what you have to do? To check the safety, now you require MR. Now, calculation of MR of cross section. Sorry, this I will not explain, but since there are 2 rows of bars are there, I will tell something about effective depth now. Otherwise, it is for you. I will make ready. Remember, the value is 120. I may forget it later. 133.206. Actually, I can find also within 10 seconds I can find. But why should I find once again when I already calculated? Okay. Now, calculation of ultimate MR. See, not my problem. Write the cross section. Actually, something happened. I rubbed the question completely. I remembered cross section is 200 by 500. I remember it. Clear cover 40, between the rows 25, I remember. Diameter of bar, I don't remember. See, I forget very easily. I think in the question I have given, beam is reinforced on tension side by 4 bars of 20 mm diameter in 2 rows of 2 bars each. Then okay. See, 2 bars here, 2 bars here. Correct. See, clear cover is 40. Between the rows, clearance is 25. Okay. But by chance, while giving the question, see, I rubbed it now. I rubbed it. While giving the question, suppose I have given 4 bars of 16 mm diameter. Actually, for this beam, I think 4 of 20 mm bar is not required. It will come over reinforced. Okay, no problem. By chance in the question, don't make an issue. If I have given by 4 bars of 16 mm diameter, then you change the question and make it 4 of 20 mm. See, if I have given 4 bars of 20 mm in 2 rows of 2 bars each is okay. That is what I am proceeding further. But by chance, if I have given, see, I don't remember. It is reinforced by 4 bars of 16 mm diameter. You change the question, make it 4 bars of 20 mm diameter. Okay, now B. D, little later. AST. See, 4 bars are there. Pi by 4 of 20 square into 4. Concrete, etc. This is known for you. Okay, now D. Effective depth. Once again I wrote. Effective depth is the distance of centroid of, I mark red color here if you want. See, one small dot. Red dot. Okay. Centroid of, say, G. I'll mark a G here to understand correctly. G, red color. Centroid of tension steel from extreme compression edge. Now, something I am telling in the class, you should write it. If you want to understand correctly, you should write it here. If you don't write, you are losing. Since both the rows are having same number of bars and are also of same diameter, centroid will be exactly midway between the rows. You are right here. Since both the rows are of same diameter, both the rows have same number of bars, 2 bars, or 3 bars, or 4 bars, anything. And also, both are, see, number should be same, then whatever is this tail, same should be this tail. Therefore, centroid will be right here, exact right here. Midway, exactly midway between the 2 rows, that is exactly midway. If this is 25, what happens now? If it is 25, correctly center. Center here. You can make a note here. If it is center, this will become 25 by 2. Okay, now very easy. Effective depth equal to 500 minus 40 minus full diameter of 20 minus, see, from here up to here you require 500 minus 40 minus full diameter is 20 minus 25 by 2, you get 427.5. Okay, make a note. Over. Now, enjoy. Find XU, find XU maximum. More will come. Worry, not worry. Over reinforced. Since more came, equal, that all your problem. Ultimate MR will come 97.67 kilonewton meter. If you cannot do, don't attend any more classes. Okay, now, check the safety. Now write, factored maximum BM is 133.206, not 706, 133.206. That already we calculated just now. Before this round, I got factored maximum BM 206. Resisting capacity is only 97. So somebody is applying a bending moment of 133. Its capacity is only how much? 97. Bill came around 1,300 rupees. Money in the pocket is only 900 odd rupees. Therefore, write not safe, question over. Somebody will ask, sir, what to do? We are asked to check the safety. They did not ask us to do anything further. But practically means you have to think. Here, theoretically, check the safety, not safe. Over. Question over. Now, make a note. This is extra information I am giving. Extra information I am giving for your benefit. Actually, I need not do. I can conclude the class now and take rest. That's all. Okay, then still. Right. In the question there, 4 bars are given, 2 of 20, 2 of 20. Both the rows are having same number of bars and are of same diameter. So, centroid will be exactly midway. Right. But suppose in the question, you should write it. It is given that there are 4 bars are there, in 2 rows are there, but a change of diameter. Bottommost row, suppose they give by 2 bars of 20 torr, in the first row, bottommost row, at a clear cover of 40, and next second row, not 20, 2 bars of 16 torr. So they told bottommost row, you should write there. If suppose in the question given, it is reinforced on tension side by 2 bars of 20 mm diameter at a clear cover of 40 millimeter, and then with the further clearance of 25 mm, there are 2 more bars of 16 mm diameter. Then your AST will be, here see, pi by 4 of 20 square into 4. Here, pi by 4 of 20 square into 2 plus pi by 4 of 16 square into 2. Okay, AST no problem. Now, problem is D. Distance from extreme compression edge to centroid of AST. Now, statement. Since the 2 rows have different diameter, centroid will not be midway between the 2 rows. See, centroid will not be here. See, it will not, see, this is 25. Centroid is not 12.5, 12.5. Therefore, first locate centroid G for AST, that is for this fully AST, locate CG. How? For 2 of 20 and 2 of 16, locate CG. How? I will explain. 1 minute. I will not go, I will write in front of you only. Rubbing part. Same thing. When I want it, I won't get. Somewhere I kept it here. Then I have to close the class and start once again. Yes, right. I got it. Okay. Now, see, I remove this one now. Just remember, when they are same diameter and same number, our D was, how much it is? It was 427.5. There is a reason for it. Okay. Now, start. I'll remove this one. See, what to do is, somewhere here, put a sketch. Cut. We want only bottom portion, that's all, only bottom. 2 bars are here, neatly. Scale is not considered. Okay, now, it is given, this is 40, scale is not used, this is 25. Then, this is the bottom edge. First, let centroid of total AST be, or centroid of AST, why total AST? Centroid of AST, that is, what AST? With the 2 of 20 torr plus 2 of 16 torr together. Be at one red color I will mark Y bar from bottom edge. Then formula. Then Y bar equal to A1Y1. I am using red color. This can be black color. Okay. Y bar equal to Y bar from where? From bottom edge. See, bottom edge. That is the reference. A1Y1 plus A2Y2 divided by 2. Okay, some people write A1 plus A2. A1 plus A2 is total area. Okay. Equal to. Area A1 is these 2 bars. This is 20 torr. This is 16 torr. This is also 16 torr. This is 20 torr. So A1, pi by 4 of 20 square, this area, one more is there, into 2. This is your A1 into distance of its center of gravity, centroid, from here. 40 plus half of 20 into that much is required. 40 plus half of 20, A1Y1 plus this area. Pi by 4 of 16 square is this area, but there are 2 bars are there, into 2 is your total. These 2 together is called A2 into distance of centroid of that row from here. 40 from here up to here. 40 plus 20, this 40 plus this diameter 20 plus full 25 plus another 16 by 2. Close, over. A1Y1, A2Y2 divided by total area. You already know it. How much? 10, but don't calculate, 30.44, because this is a total. Already we know it. Total. You get the value of Y bar in millimeter. See, 1 minute. One thing I will tell now. If they are same diameter, Y bar from here will be 40 plus 20 plus 12.5. 72.5. See, from 500, 72.5, you got 427.5. Now, surely it will come little lesser. Y means don't bother. Okay, now start calculate. Pi by 4 is not required. I required. I had calculate now. Pi by 4, calculate not working properly. Pi by 4 of 20 square into 2 into bracket 40 plus 10, close the bracket, equal to plus bracket open, pi by 4 of 16 square into 2, that's all. Close the bracket, into again bracket 40 plus 20, I am doing carefully 25 plus 8 equal to, divide by 1030.44, 66.78 millimeter. 66.78 millimeter. I will check once again if you want. 1 minute. Check martibidi. Now I will check the easiest way. I will tell 20 square into bracket 40 plus 10 plus 16 square into bracket 40 plus 20 plus 25 plus 8 equal to, divide by bracket, shortcut 20 square plus 16 square. Yes, correct, 66.78. I did something else, don't worry. Over. Now, what to do is, okay, this is over. Now, one more sketch right here. Now, come back here. Come here. Put one sketch. Okay, now do one thing. Now write the sketch once again. See, now, this sketch, write once again and mark CG. See, this is 66.8. 40 plus 20. How much? 60. Somewhere here. This is the centroidal axis. This is your G. From bottom edge to G will be your Y bar of 66.78 millimeter. Write one more sketch. Okay. Now your D will be from extreme edge up here is D. Okay. Red color will do. Now your D equal to 500 minus 66.78. So instead of earlier D, how much you got? 427.5. It will come slightly more. 500 minus 66.78. 433.22. 10 mm more. 433.22 millimeter is D. Okay. Earlier you got how much? 4 to, or I will tell percentage change if you want will be compared to last time not much. 433.22 minus 427.5 divided by 427.5 into 100. 1.338%. That is a shift of 1.338% compared to last time. Now, one information. Academically or examination given, you have to do this way. Usually what they do is, they know the difficulties. If they give 2 of 20 mm here, they'll give 2 of 20 mm only here. They don't want to give trouble to students. But remember, practically what people will do is, they will not bother. They will calculate D to center. Then they will get 427.5. Means they will get slightly lesser D than actual D. Actual D is little more. They will consider lesser. It is safer side. If you consider, people will tell in the design office, don't bother, I say. Take to center and go further. Don't bother about it. Even practically, I also do same thing. For when I do project or building design here, I will tell if diameters are different, take to center and go ahead further. Do not bother about that 5 mm, 10 mm like that. But technically, you have to do this way. Okay, over now. Single A in post over. Next class will be WA in post section. Thank you.